This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Hello everybody. How are you all doing? Just before the break. Happy that it's before the break. Me too. So you've all submitted assignment 3, first part, assignment 3. How did that go in general? Talk to me with any feedback, comments. What do you think? Hard work? Okay. This was expected, so well done. Anything else you would like to share with me?
What we are just generally curious about it, while in the middle of implementing one of the learning processes, if we see another resource that while in the implementation process we find was really good, but we didn't find a strong design report, can we incorporate that?
Can definitely add that, yes.
So
If
do
it's
we-
adding a value to your project, add that.
So do we say
Or if
something
it's
like
simplifying things, do that.
so do we say something in our appendix that we didn't point out this resource in our design report, but we're using this because somehow.
Yes. I'm not going to say we won't be looking at your proposal when marking the final project.
Of course.
However, like if it's a total mismatch, then we'll be like, what's going on? But not every detail. So if you find a new resource or it's something that can make your life easier, a different analysis, than what you thought originally, you can definitely do that.
So I guess we can create like a formal document which will be like, okay, new things that we found out, and this is what's different from the design report. I don't know, sort of standardized.
Okay. some
important. You
examples
can
for
create something good for the team. We are not doing something in another time. If I want to spend time with this thing,
Yeah.
create something that is valuable.
Good point. I'll pass that on and maybe. Thank you. Any other comments or complaints? Well, I've heard a couple comments myself, or I've read them in an email. Let's say there was a question about that in discussion as well, which I'm sorry I haven't read early enough because I was in hospital towards the end of last week. And that's about the personal contribution. Not a personal contribution, the personal assessment of how it's achieved. I have a comment about it. So the last part of what you'll be assessed in the first, both in the first part of assignment 3 and the third one is your own judgment. However, it's not how much work you've done. This is not a peer assessment. You'll still be marked as a group. It's your own reflection on understanding of the project. If you think it's going to work, if you think it's not going to work, if it could be done more efficiently, how other things could be added on top of what you've already planned, it's your understanding of the project. That's what we'll be marking. It's not, we're not going to compare, have you actually done this amount of work? We can't even, we don't know. We can't find out. That's something which has to be discussed within the team. But it's your own understanding. And I believe that's actually the best way how we who are going to assess your assignments, see how much you actually could contribute based on your understanding. Now, if you've copied something from your colleagues, your personal reflection is the same as your colleagues, then there's plagiarism. It will be the same person reading everything, so they can definitely see some similarities. So I believe we will be able to discover that. But I understand that this is a tricky project, and not every group has a perfect environment for working in a team. So if that is the case or something, then feel free to get in touch with me, and we can solve it out personally on a professional level. Because it's in everybody's interest to have a good working team to make the best possible results you can. It's in my interest as well. So if there's anything happening even throughout the process, then get in touch with me. Usually, from my experience, it's a lack of communication. Somebody got sick or other things came on and they were not able to effectively communicate it to their team members or things. So it's better to sort these things before we will get into some anger stage, let's say. Okay? So that's on that. And let's talk about today. So today we'll be talking about qualitative spatial information. What do I mean by that? It's what we add on top of what we know with GIS. It's the added value information, what we can build on. So in contrast what we have done so far, that until now we talked about qualitative information, we talked about numbers, quantities, 1, 2, 3, you can do all sorts of calculations, so you can have certain number variations as a proof that some phenomena is happening or not. So it's really easy, and I would encourage you, if you can do it with quantitative information, do that. However, we humans more often think in qualitative information. So if you think yourself when you're arguing with somebody, you can say, no, it's not too far, it's close, we can get there, you'll be there in a few minutes. You're not using the exact numbers, you're not saying it's 225 meters, you should be able to get there, you're using close and far. You're using a different vocabulary, you're using a language which is qualitative in nature, it's not quantitative. So how we think generally is in qualities. Yep.
So just sort of like a week 1
notes yeah, don't worry, you'll see. I'll explain that. It can seem counterintuitive, but we can have qualitative information in GIS systems as well as quantitative.
Will decisions be based made on purely qualitative facts? Can big decisions be made today?
Big decisions can be made and are made, but it depends. There has to be some agreed language. It's so easy to have it done with quantities because math is widely agreed communication language already. Everybody understands the sequence of the numbers, operators in math and algebra, so that's all globally agreed on. If you want to agree or make an argument or reasoning with qualitative information, you need to have a common language for it. That needs to be defined. I'll be talking about that. You're already thinking ahead of me. That's good. So it requires us to understand the logic that we put behind quantitative information. The mathematical logic is all good. We all understand that. Then the quantitative is something we need to decide on. Very general definition. What is a qualitative information? This is a very circular definition. I would actually not encourage you to use it very often. Circular definitions are not good. Information about qualities. So, as I've already said, it's something we can observe but not measure. I can observe the color of your clothes, but I can't really measure them. But if I agree on some color scheme or color information, then I can put it in numbers and then I can compare that. But originally, if I just look at you, I see colors. That's a quality. It's a characteristic of the quality. Yep. I can't really measure things. Or if I look, for example, I can trace it back to the electromagnetic spectrum where I can have numbers, but that may be still confusing because colors are perceived subjectively. So let's stick with that. It's a qualitative characteristic. I suppose if I will look at your height, because that's something I can measure. So if I say the tropics are humid, and you understand what the word humid is, you can then see the quality of the tropical forest. You can imagine that just from the description. If I would tell you that there is a 600 millimeters a year of precipitation, 600 millimeters of precipitation per year in some area, would you actually get that image, what it means? Not really. Unless you're really familiar with the numbers, you can't really tell if it's humid or not. So that's why we describe and argue as humans more commonly with the qualities. And I need to pay attention to what I'm saying because it's very easy to swap those two. So again, term humid is not exactly agreed. It's not like saying that between this and this interval of rainfall it equals it's humid. It's all bunch of different variables. And it's not just like line in a sand that this is from now on we can call it humid, before then it's dry. It's a bit of a fuzzy line, you can't tell where it starts or ends. Again, more examples, you can say that I'm tall. In a relationship, if I'm with my family, with my brothers, I'm actually not that tall. So it's all relative. You can say the wind is strong, but how strong is strong? Again, you need to agree on the common language, on the definition of what is what, when we can use these terms for arguing. The lecture can be boring. The statistical area is wealthy. Again, it's all relative. Different areas, different countries, for different people, wealthy is a different number. So qualitative information
generally explains the relationships. It explains the relationships between objects. There is an example that the whiteboard is in front of you. However, if you turn your head, would you still say that it's in front of you? If I'm standing like this, it's in front of me, but if I look like that, it's still in front of me? Maybe, but we would have to agree if it's in front of my eyes or if it's in front of my chest, the center of my body. Again, that's something you need to decide on if you want to explain things like that, something that are in front of you. Other examples, Colorado is not too far. Or Pepper example before yesterday. Because we know how they go, we can then skip the discussion, we can about the definition, and we can go directly into the day before yesterday was today minus 2. You actually don't need this explanation in a database. You don't need this special calculation that the day before yesterday equaled today minus 2. You can reason with that just from knowing the relationship. It's an illustrative example with a time scale showing all possibilities that can happen between the green and the red event. So I can have that the green event happened before the red one, and it can happen at the same time, or the green event can happen after the red one. So there's 3 cases, 3 different relationships between these 2 events. It's good to know all these combinations because if you happen to, for example, program a user-defined application for GIS and you want to show in a loop if this happened, else blah blah, this happened, you will have to list all of these possibilities to actually show them to your user. So I have an example here. How many relationships can be distinguished between 2 time intervals? I'll put it up in a minute for with the poll. So just to mention that here it's a point, it's 1 point in time, but now I'm talking about the interval. It's a 1 event, longer. So think about how many relationships there can be between 2 time intervals. Before it was 1 point in time, or 2 points in time, and now we're talking about 2 intervals. How many relationships do you think there will be? Do I have all of your answers? Are you sure with your answers? Or do you want to change them? Really, half of the class thinks there's 5. Interesting. You think there's 6? Well, there's 6 plus. So this is the solution. And there actually is 13 cases. These are all the events drawn that can occur in time, all the combinations. We can have one event before the other, those two. One can start right, the other one finishes. Again, 2 cases. Same case for combination of both, that one will start after first one, or while the first one is still happening. Can start at the same time, finish at a different time, start at a different time, finish at the same time, within the other time, exactly the same. Altogether 13 events. So it's 13 different qualities of what can happen with these events. We're not interested in a distance. I'm not measuring the time in between those 2 events. I'm just listing the cases. Of all the cases, what can happen, this is what I'm doing. Does it make sense? So other qualitative spatial relationships. Okay, let's just actually go back a little. So this is a time when we know that time is one directional. So time started, sometime back with the Big Bang, and it's only going forward. However, what would be the case if how we would distinguish this in a space? Because space is not directed. Space is everywhere around us. Can you imagine how the options would actually expand in a space? Because with time it's given you can only go forward. So it's actually easier for our logic to process the time. But then when you think about space, what would be the options? I'll talk about it in a minute. This is just to give you some idea with that.
Because like one other relation could be the time interval is of specific length and the other time interval doesn't go.
No, the length is not important for this relationship argument, unless you're saying that they both have the same length. That's the case, that they both start at the same time and finish at the same time. That's what you're talking about. But you're not interested in the length. You're not arguing with the length. You're arguing with why that they took exactly the same.
Because I'm just thinking in terms of processes, that one process when once it, because the example, one of the examples was that one process in one time interval finishes, the other starts and it's
Yeah.
It's very similar to like certain processes in manufacturing. So
Yeah.
something could be like if one process will certain length, the other cannot be performed, cannot be performed. Like
Yeah.
something. So maybe that could be a quantity or greater. But if
That would be quality dependent.
yeah. So what I'm saying is that are these just like really well-defined categories?
So let's say these are 2 independent events. What you're talking about would be that I'm adding another rule, saying that B cannot happen unless A happened. Then I would have different sets of options. Yeah? But as I mentioned with the space, if we think about spatial relations, there's definitely more. This is just a list of few. Some relationships that are agreed on or discussed or assessed formally. Qualities that has been assessed formally within the spatial science field. First one is topological relations, and I will talk about some of them in more detail after this slide as well. This is just a list. So first one, we have topological relationships, which means that are invariant to reference frames. What does it mean by that? What do I mean by that? if I say that a certain object is within another object, even if I transform, do a, let's say, coordinate system transformation, or use a different, distort the shapes somehow, I will not change the information that one object is within another. Even if I distort the shape and size, the information that one is inside another is still the same. That is topological relationship. Cardinal direction, something is north of or south of. Again, global definition where we have north and south. It would stay when we're on a planet or based on our reference point. Also, relative directions, something we agreed on. I have in front of me, right, left hand, so anything which is on this side is on my right, or your right. Again, the relative directions are agreed on. And there's also some vocabulary when we talk about distance directions. Something is near and close, and something is far. So you can understand the language, you can imagine what things can happen, but it all depends on the context. There's a question for you. Notice a state library, this block over here. So how would you describe things that are north of state library? With your spatial thinking. Let's start with it. This is state library. How would you describe everything that's north of? How would you define that north of?
Anything from a clean slate can be defined as north. Anything which is that's
Anything that's in front of it is north.
if we define the, like, for example, my face is front for me, the same way for state library, if I define the gate
The
entrance,
front of the building.
yeah, I define that as the front, that becomes north. If that's the definition.
You mean that the front of the building is just north.
Yeah, if
You're
you
more talking about the general north direction. Think about the north as a global.
Less latitude values.
Yeah. You think that this map is oriented north. No, there's no, it's just cut from. There's no north arrows. The map is oriented north. How would you define it when you want to define everything that's north? Good thinking, yeah, you can draw a cone, something like that, yeah. Or you can simply draw a line.
We say latitude values. You know, it is north, it is south,
Yeah,
it is west,
yeah.
it's more
So you
latitude
get
values.
the
define-
coordinates of the North Library and any values that are
Only the
higher
latitude.
and are bigger than this. You can say that that's north of, yeah. Good
Going
thinking.
to the equator, maybe are smaller.
Yeah, if that would be south. You start at 0 and you're going north, you're increasing the value. That's okay.
You have to keep the northwest point of the line.
North, if the point is
You can't be at the center,
So that's to be small.
slightly more than
Only because you have a line to be smaller.
like here,
No, say if you pick the center of the line as
yes, yeah, yeah.
anything north of that.
Anything north of the centroid of the library, yeah. See, well, we kind of use this language intuitively, but as you can see, we can come up with more definitions just for a simple north. So if you're trying to program an application, you will need to be sure, you need to know all of your rules of north definition. I'll show you some later. And a similar exercise you can do for the language of near, far, left of, inside. Left of, that was a good when you say that you define the front of the building. And then you can have the front of the building as the front, and then you can take the left from the building will then have also left and right.
Facing which way?
Facing which way? That's a good question, because it depends if I'm talking about the observer or if I'm talking about the building. So the building would have left and right side by itself, but the observer, if it's facing it like I'm facing you, then my right is on a different side than your right. Just because we're facing different way. So it's a good point. I'll have an image about that later. So generally we're using, also if you know that the qualitative information is explaining relationships, we can use it for reasoning. Here I would just have a note, if you can reason with qualitative information, go there because it's much easier and practical. So if you can have an argument with numbers, do it with numbers. Everybody understands numbers if you explain them well, if you put in units and things. So if you could argue with numbers, argue with numbers. However, if you can't, the qualitative information is here for the reasoning. It helps us save, let's say, brain space and logical space in a database as well. And if you define a relationship for A and the relationship for B, you may be able to derive an information for a relationship for C. An example, if A is inside the B and B is inside C, then A must be inside C. Practical example, if Melbourne is in Victoria and Victoria is in Australia, we can say that Melbourne is in Australia, just from a simple logic, but it is defined logic. It's not a mathematical logic, it's defined logic. So we didn't have to store the information that Melbourne is in Australia. We can retrieve that information both from a database and from our thinking, just by the logical reasoning, by knowing the rules. However, careful, it can also be ambiguous at times. So if I say that A is far from B and B is far from C, can I say that A is far from C? Well, it may not. It may be the case, but it also may not. So sometimes it can be tricky. Careful with that. So why do we actually argue with qualitative information? So we're entering a territory of artificial intelligence, and it's easy for the machines to process numbers, do calculations, plus minus and all of these things. But again, as you might remember from the first lecture, it's us who actually gives it the meaning. So if we say that a certain number of precipitation is not enough, it equals that certain things are dry, then you have to define it in the system, in the database. So it's not the artificial intelligence who actually decides on what's dry and what's not. It's you as the creator of the application and the user trying to communicate things, information that is useful. Why do we do that? Just to make life easier for us. Because artificial intelligence is definitely the way that can simplify things for us. However, we need to define the rules as we want them. So it's a reason for simplification. The point is, qualitative reasoning or any qualitative relationship calculations are expensive and complex. So when it comes to quantity, as I mentioned before, it's easy to do a numerical calculation if you can do that. However, if not, you can have a system that will do a qualitative reasoning, but you need to be very precise and need to define it as much as you can. Think of it that you define that you're creating your own calculator, but you're creating your own operations within that as well. So if you would start creating a calculator from scratch with all of the possible relationships, all of the possible options, you need to list them in your system if you wanted to communicate and simplify the life for yourself. So you need to know all of the cases of the line of the 2 time intervals. all of the cases of 2-point intervals, to show them one after another. Because again, it will be eventually used by people, and people argue with qualities, not quantities. Notice that next time you're telling that to somebody that it's not too far, you're saying it's not too far. You're not saying it's 1.25 kilometers. Yeah. So many applications can be used for reasoning, route direction, language. Language is coming. It's gonna be more and more. Just notice as well, with again an example with the car navigations. The change came about 10 years ago, but back in the day, the car navigation would say in 350 meters turn right. Now it tells you turn right at the next turn. It dropped the distance information and just let the driver focus on what is actually the next turn. You're saying next turn, you're not saying 250 meters or something. Because again, it's hard for people to judge the distance, then again depends on the speed. So this is actually much more useful and fast information to communicate where do you need to turn. But again, this is an information that comes to the user through voice, and voice is starting to having more and more application, including GIS systems. I don't know, maybe you remember there was this joke. It's a funny video, I'm not sure if you've come across that. Some Scottish people were in a lift and they were trying to tell the number of floor they wanted to go, but the lift didn't understand them. So if you're designing something, you need to be sure that the system understands the people. Or if you say something to Siri or whoever the Windows name is, they have troubles with me because I have an accent. So you need to define the language as well. So you need to make sure that the interaction between the humans and the computer is actually really the point on, that they can understand each other. So the voice interface at both parties need to be defined with many ways. And at the same time, if the voice is talking to me with an accent or language I don't understand, it has no use to me. Okay, this says voice interface, but it's actually more of a showing the definition. Look at this side with the at and on. What I mean. So in English, some of the prepositions and semantics in languages are different. That's what we need to keep in mind. That, wait, I'm going crazy. But the English on has about 3 different prepositions in Dutch language. An English word at has no equivalent in German, and it would have about 3 different equivalents in my language, which is Czech. I'm not sure, and I'm sure that in your own language as well, in Mandarin or your native language, you can also see the differences when you're learning the prepositions. How in your language it makes sense in some way, but in English you can't actually explain where am I? Like, where is that? For example, in Czech we would say, I'm sitting in front of a computer, but in English I've been told that it doesn't make much sense. So I stopped using that. So it is something that needs to be formalized, especially if we're using AI, the artificial intelligence. We need to formalize, we need to define all of these options, what this means. And it's because language is flexible. The context is everything in this case, and if you're trying to describe to your friends where your position is or what's happening, and they don't understand you, you can just keep throwing different explanations at them until they really understand where you are. But there's a limit of functionality when it comes to AI. So everything needs to be clearly defined. Also, relationships between here and there. In English, it's quite vague. I can use it interchangeably sometimes in the same sentence, and some other languages may not be that vague. But if it's here, it's really just like here, here. But there, what is there? Like, or how far is there? Where do I actually point? So there's challenges with words. Also on this picture, there's a picture of tree and the person. So as you mentioned, the building, there are objects that have faces and relative directions on their own. So the state library, we can decide what's the front, and we can say what are the sides and what's the back of the building. But we can't say that about the tree, for example. You can't say this is the front of the tree or the side of the tree. The tree has the same phase, let's say one phase all around. So if I say that the ball is left from the tree, I mean it from the position of the viewer, because the tree itself can't really have special phase position. Okay, so I have another question coming. So can you interpret the spatial preposition at, by, and now we have options. Just turn this off. So can you interpret the spatial preposition at, by? Either topological, the relations, cardinal direction relations, relative direction relations, or distance relations. What is topological information? What it is? It's the relationship between, for example, lines or different areas, different shapes. What are cardinal directions? North, east. What are relative directions and distance? Any more answers coming? Oh, it's changing. What's going on? Okay, generally speaking, topological relationship is correct. If you think about it, if I'm at uni, I will still be at uni, even if I will draw it differently in my shape, on my map. Cardinal directions, nobody answered. Could be if I'm like really, really lenient with the definition. Also relative direction relationships, that's definitely possible. So this answer C is correct as well. We can say that I'm at uni. If we define where is at or how far it would be from or like within a certain buffer from certain place, we could use relative direction. Not sure about distance, but maybe if we define that if it's within 25 meters or something from a place, could be. But the point of this is you can already see how it's ambiguous and it's just one preposition. And yeah, actually, relative direction pointing direction should be just the front, back, and right side, like something which we define and they say, and if we don't say at, then that can be actually confusing.
Distance be relevant, but even saying at for distance is very confusing. But
If you define it,
you could say something like there's a central position, like
yeah,
the university's like main building, right?
yeah,
We can say that this building at this place, which is this far from the main
mm,
building. So I can see a site there.
yeah, yeah. So there could be that. Yes, yeah, you're right. Yeah, could be. This is a thinking exercise even for me. So let's look at some of the examples before we break to the break. So topological relationships. They were formally described by the gentleman Max Egenhofer, and they're actually very well described. And I'm sure you all came across topology when we talk about, we had topological algebra before, but topology is the information about the relationships between shapes and features. A typical example, if I have in reality, if I have a crossing of railway and a road, I can have three different options. They can meet on the same level, or railway can be under, or railway can be over. So three options for meeting of these two different lines. That is a topological information. And then if I present that in a map, in a GIS system, I want to keep the information. So if they do meet, there needs to be a note. They do meet. If one is going over, then one should be drawn over. If one is going under, when I'm visualizing the map, it should be drawn that it's under. So I'm keeping the topological information from reality as it is even in my map. So definition says that it's a geometry that is invariant under groups of continuous transformation. So it's the part of geometry that does not vary when we do distortions. So even if I completely distort the image of those two lines of the railway and the road, it will still show that one is underneath another, even if I stretch the picture in many ways. Like I was saying with that example, if something is inside, it will stay inside regardless of how much I would change the shape. But non-continuous transformations, that's when it will change. So if I cut the image, I'm cutting through. I might actually then change the shapes. So cutting, inserting, removing, but then it will change even the topology. An example in an abstracted geometry. So we have a underground map from Vienna. So you can see the railway lines. So we can quantify the distances between these stops. This is a stop. We can look at the distances. However, if we symbolize that, now we distorted the distance information, so I won't be able to measure the difference between these two stops, but I can clearly see the relationships between two different stops, or every stop there is. So the relationship between the lines is kept, but the geometry information of distance is gone. Maybe I can count the distance in a different way though. I can maybe count that it will take me, it's 3 stops, I can count the stops. But again, that is even though it's a number, it's actually a qualitative information. So mainly these kind of schemes, they preserve relationship between the connections. So you can see that in here, there there is a clear connection point, even though it's drawn that they may not be. There is, you can change from one to another. Yes.
What was the example of non-continuous transformation? Looking at the road and railway example,
Yeah.
I think let's say we're adding something like more buses as a new list. You're inserting another,
Over buses.
like more buses, like roads that go above the regular level, like bridges that go like something like that. Just sort of like thinking out of the box. So like in that sense, how will that transform the underlying qualities? Because the railroad would still be under the road, but it would be maybe asking the question creating like this like I'm not sure in what context non-continuous transformation changes the qualities and of the topological interpretation. So
Getting confused. So you're not sure when the non-continuous transformation
what is an example of
changes.
practical non-continuous transformation affecting an underlying map that was used for some?
Then I just cut out half of the image. It's a non-continuous transformation.
And are we saying that that half of the image was important to understanding? Are we saying that half of the image that was cut out was important to defining the underlying qualities of that map?
Now I would have to cut it through both of these features. Kind of decide, oh, I can't. I'm cutting, but I only keep this in because I need to preserve information. Just if I draw that, you will lose that information basically. You have one line and another. But if I then decide to cut all of this off, I don't know if this information is there, like it's gone.
So we lose that quality of
So
the
you lose that quality information, yeah. So you can no longer argue that it's actually there. Because you've cut that information off. Yeah, I've already mentioned that we can use this kind of schemes for describing routes. So you can count the stops. We can have them as action nodes. We can add some landmarks. Where we need to transfer at a different node and so on. Or we can say next stop will be Burgasa and so on. When we talk about regions with topology, if you remember when we talked about Jordan's theorem, that a simple curve separates the inside from the outside. So that's the same principle here. I'll do some drawing later. But generally we have the interior of a shape, we have the exterior, and we have the boundary. And then we can describe the three different groups, and then we can describe the relationships between those three different groups. Imagine that that there will be points in the interior, points in the exterior, points on the boundary. We can say that these sets are topologically invariant. Even if I change the shape of this shape, I will still have interior, exterior, and the boundary. If I deform it, it will keep the relationship between those three will be the same. The shapes on your right, you can see that they look different, those two, but they have the same relationships. Almost exactly the same. Even though they look different, you can still say that the blue one shares a boundary with this beige, and there's an outside from all of them. You can see different shapes, but the same topological relationship between them. So that's the homomorphism. So I'm preserving topological properties. Imagine that this is the reality, and I'm adding it into a raster. I'm changing the shape. but I want to keep the relationship that this is the boundary, this is on top of one other shape or the other. These are all of the cases when we have two regions, all topological intersections between two different regions. And we have defined the inside and the boundary. These are all of the combinations. That's how it can be written in a logical way. Example. So we have intersections of the interiors. That's the first one, AI and BI, intersection of two interiors. We can have an intersection of the first boundary and interior of the second shape B, or I can have an intersection of the shape A and boundary B, or I can have an intersection between two boundaries. And these are all of the combinations I can have. And I'm interested in how big the intersection is. I want to know if the intersection is fulfilled or if it's empty. If there is a topological relationship, it will create a complete set. Might be a familiar language from graphs and networks, complete set. So if there is a relationship, then we can say that it is a complete set. Some notation. So this symbol is used based on those forms. This symbol is used if there is an empty set, and this symbol is used if there is a relationship. And we can check all of those 4 different relationships for each of those cases. So we have no relationship. In this case, we can see that the boundary is touching, and so on. That's how we can describe the relationships, have a relationship matrix for all of these cases. So when we look at the interior and the boundary of two shapes, we can have 8 different cases. Yep. This is the terminology that Max Egenhofer decided. It covers, contains, meets, disjoint. Again, it's just a language. It's what he decided, what he created. You can decide on your own terminology in your own application. Then the question is if somebody will understand that. But the thing is, the language is flexible, but the situation will be the same. It looks quite simple, right? You can logically get that. However, it gets more complex if we introduce the exterior into the equation. So suddenly the matrix is much more complicated. So we would have 9 intersection matrix points between any 2 regions. Oh, it's actually when I'm adding that, yeah. Any 2 regions or lines, or region and a line and a B, when I add the exterior in the equation. Just skip this so we can have a break. So all of these 8 relationships, those 8 can be connected into a conceptual model. Think of this, that these are 2 objects that are moving, and if they're far from each other, the only thing they can do is to touch. And as Max Egenhofer will call it the disjoint. So the only thing they can do, the only relationship they can have from not having no, they can then touch. So they disjoint, they just meet, let's touch at one point. From there they can overlap, and once they overlap, I can go into 3 different relationships. Oh no, just 2. They can be completely covered or just covered. And again, this is a conceptual model how these two features can change a relationship if they're, for example, moving. Or this actually can be explained by changes in the matrix as well. Okay. Never mind. A model, no need to memorize this, but this is showing all the relationships between lines and regions. So there's 19 line region relationships that can be formalized, 9 intersections, 9 different interactions, 19 different interactions, and 9 interactions. So 19 relationships altogether, and just 9 when they intersect. Yeah. And then we can go even more complex. This is 33 topological relationships between 2 lines, and so on. Okay, we can skip this question and have a break. 5-minute break. And after that we can start with a question. Maybe. After the break, actually, we'll have today's presenters. So this is the order, how I've organized the slides. So you can get ready on the side. Let's put that up. Yes. Sorry, I need to. Let's go. Like error. the road and the railway. How these two can interact. So maybe we do roads. Maybe I'll do yeah. So I would be
I missed the last one as well, so a bunch of questions. One thing I understood the idea that the transaction time would usually be lower like when an interesting event happens or decide after the event that this is something unless you choose to put it in and the point you made that actually work out is usually something that
oh, the valid time is when it happens, when
Yeah.
it is in reality. And the transaction is when it's written down.
so one part I was a little confused about is that are there multiple transaction time let's say a stock if we're going to get a stock market because
Yeah, but you can have the next one. Look at this, so you can transaction from and to. It can be a period on your recording these things. Even the transaction time can have the let's say the person writing it down has a period when they have to note and then nobody really checks it, they do it one day of Friday. So you have sometime this is even and you can have that connection immediately. Those podcasts will be
like when I'm looking at these kind of differences these significantly big and I'm watching in the stock market but everything transactions are done in very small things and I imagine that like after the first transaction like we do an IPO where your public company goes to set your first market value then everything has to be done in real time in the system so I imagine that after the first DD only DD is important or is it, to make for example future predictions
I guess for that, yes.
So-
For that example, yes. I don't kind of when I wrote it down. So it's that time when it happened.
exactly because it is
Unless you want to use it very hard.
But in this context, when we're looking at like any sort of prediction, like how do I interpret DD and DB? Because we talked about this also being capable of making this sort of recording style of data to be capable of making predictions. So intuitively, which data interval do I look at? Do I look at DD from DD2 or do I look at DD from DD2?
No, you're not making predictions.
Oh,
You're from the database, basically. You already know that something will be bought in the future. So let's say I agree I'm gonna buy this parcel,
Right,
but I have not yet done it formally.
right.
But everybody already knows and the administrative clerk can already put in the database. That they know ahead of time that then will happen.
Right.
They kind of already dictate that.
So it's like some sort of like agreed contractual.
Yeah. Think about it when it comes to weather. Predicting that it will, that it will be warmer in 3 months. Predict that like the season I can predict that. For example, making my own calendar, I can mark ahead of the plan. So that's it's gonna be more because of the summer. I'm predicting that. I'm not waiting for the time when it happens. Like and now it's happening.
But in that context, what would be because let's say it's December, and in December, in that context, what
That's
happens?
something quite fuzzy.
Yeah.
Not the best example.
Because would it be like a scientist comes and says, okay, 3 months later, I know it'll be 5 degrees centigrade on average, and December 30th,
Or it could be again on the agreed information. We say the first summer day start by the 30th of month, or the 21st, or the summer you want to stay.
yeah,
That would be agreed.
very fuzzy when the word prediction is used now, because it's like,
It is very fuzzy. Yes, it's very fuzzy. So then don't worry about prediction. Don't use prediction. It's really the cases when I know that it will happen, but not yet officially happened, but I already want to have it in it.
and what's the important relationship
Okay. Ask me after. So we have today's presenters. I'll manage to make this full screen. It's a reading mode, never mind. So whoever is the first one can start. We don't have much time. Okay, so the article that I chose was published by Gizmodo. It discusses a report by the Global Preparedness Monitoring Board. That report discussed how the world is unprepared for a new pandemic. The first map up there, this map uses a Robinson projection, which doesn't try and preserve area or angle or distance. It instead is mostly for aesthetic purposes to make the world look good. So this makes it obvious that the map isn't used for analysis or research purposes. It instead just gives an overview of the problem. The second map here, it shows the projected economic risk that each country faces for a pandemic. As you can see, the key here, it shows a gradient scale, but the actual map only uses 3 colors. So this is obviously a kind of manipulation of the data by the authors of the report, and it helps support the argument that the poorer countries are going to be more affected than the richer countries, especially the colors that they chose help support that. Yeah, that's about it. You can be ready and come up faster, thank you.
Hello everyone, my name is Frank, and this article is about the rise and the fall of America's biggest cities. And the author used a bunch of maps to show the most popular place in United States at different times. And from the map, we can see how to determine the popular of the place is through the population of the place. And I think this map is well visualize the data on this map, and you can find the clear visibility of the label and all the data. You can find the link provided at the bottom of the map. In addition to these points, and we also found some shortcoming of this map. For example, it lacks some basic elements of just like narrow area and scale, and if we use the different color level to classify the region, it will be better. That's all.
Hello everyone. The article I'm going to share today is news from the BBC News. The name is "The County Lines More Than 4,000 Londoners Identified in Just Scam." And this article is published on September 19th. And the article is a report of the statistics of London City Health, and the data is also from the research. The purpose of this map is to show the number of people identified or suspected who has been required by drug scams from each content in London. And the advantage of this map is including this map can easily understand, and the blue granted color choose is good. The reader can easily understand what county have many more people. And the title of this map is clear, and with the detail including the time of the data. And finally, this map is well connected to the news. And the disadvantage of the map including there's no north arrow and no scouts, and the source of the data is unclear. Thank you.
Good afternoon, everyone. The topic that I've chosen is climate strikes that happened over the last week. So the author in this map actually depicted the number of planned protest sites as well as the amount of people who turned up. There were in total around 2,000 planned protest sites. The strikes actually is going to happen for the next 1 week as well. So if we talk about the pros of this map, the author has actually clearly depicted his message by having the green leaves as representing the protest sites and the human icons representing the number of people who turned up at these sites. The author has also used a good color scheme, and the north arrow is also present. But if we talk about the cons, a lot of things in this map are missing. Starting with the title of the map is missing. There is no legend present. There is no scale as well as present, and the date is also missing. And finally, the author didn't really talk about his name or where the map came from. Thank you.
Hi everyone. This news is about the bus crash happened last week in Utah, and the map shows the location of the accident. The map has some basic elements such as north arrow scale, and we know the source of the map. Also, we know the exact location and the relative location. It's at the south of the Utah. The readers can easily know the bus crash location because it uses a point to remind, which is obviously. However, it has some drawbacks. There's no title, author, and legend of the map, and the readers may not know the meaning of the blue label and the row number. Besides, the color is simplex. They don't know if the green area represents the forest, then they will not know the terrain of the accident. The map can add these elements to show the terrain of the surroundings to see if whether the terrain is related to an accident. In addition, can also mark the roads with multiple accidents on the roads of the map to help readers understand the situation. Thank you.
Hello everyone. The map that I have chosen to present is about the usage of GIS in mental health and substance use disorders. I guess what I like about the map is the usage of the fact that it's a web map and the way they have chosen to show all the information at the same time, not to clutter the map. As you can see, there are some map elements, especially the title and the description is well laid out. But then there are some missing. For example, there is no north arrow and there is no scale as such. There is a good use of colors, given it's a problem that they are talking about, and the color as it gets higher, it indicates a problem in there. Now the most important points here is the map is interactive as well as it's animated. The bottom left, where we see this play icon, is used to animate the change in numbers across years from 1990 to 2017. Without that, they would have ended up using multiple maps to show the same thing, but this way it's a very good use of the properties. Thank you.
Hello everyone. This piece of news introduced there was a bushfire in Stradbroke Island just before school holiday. It was caused by a lightning strike on Tuesday night. The piece of news used an animated raster graphic file to indicate the spread of smoke under influence of winds. The objective of this piece of news is to inform viewers the status of bushfire, its potential development, threats, and seriousness. The advantage to use the geographic information is the animated raster graphic file could visualize spreads of smoke, and citation is provided to explain how winds influence. However, the information has some disadvantages. It has no title, no scale information. In addition, to better support the news, more detailed map should be provided. Furthermore, the citation is not clear enough that viewers may have no idea what the pink lines are. So that would,
Hello everyone. The newspaper article I found was published by BBC News, and it's about the departure of the biggest Arctic expedition for the study of climate change. So the map is to show the expedition path on the Arctic for a year. The good things about the map is that it has a clear title and an accurate satellite map with longitude and latitude to make the map conform to reality and understandable. And it has appropriate annotations like timestamps and some brief text for explanation. And these annotations are clean and they won't distract us. Also, the map is easy to read as it has good colors and uses clear lines to represent the expedition path. However, it lacks many essential elements like legend, scale, spatial reference frame, and north arrow. And also, it has incomplete production information as it doesn't display the author and the date. And finally, it doesn't display the country boundaries. Thank you.
Hello everyone, the news topic is climate change is bringing a new world of bushfires, and the map in this article has some advantages such as it has good legend, and the colors it pick is quite clear, and it do have some sports that shows the biggest major cities in Australia, but it do miss something such as it don't have any scale, or you don't have the north arrow, and the title is kind of ambiguous. It must be more specific, and it doesn't have any data source shows how these things analyzes, and don't have a specific time of the map. That's all.
Hello and good afternoon guys, my name is Rahul. So today I'm going to present you this map that was published in Sky News which depicts the global climate change protest on 20th September. So this map is basically a screenshot of interactive map which is also present in that article, and this map basically it lacks in certain areas which I'm going to discuss. So first of all, you can see that there is no scale to define the distribution of the data, and next we are missing a north arrow, which is very important for maps northern alignment, and then we have no legend to describe the symbology used in the map, and there is no citation provided for the data that is from where it has been obtained. And then there are a few countries which are named in the political boundaries, but not all of them are present, so that is also a con. And there is an insert map in the screen grab, but it's not present fully, so there is no understanding from here. Thank you.
Good afternoon, everyone. This map is published in BBC News, and in this map it talks about in a UK that there are certain gang who are recruiting certain age group people. They are suspected low in a particular regions. The good thing about the map, it has a clear title, and it has used different colors, and it has a legend, and it has a clear boundary as well. The major drawbacks about this map is that there is no scale and no compass. As we see in the map, it has an outdated data, like it from Jan 2018 to April 2019, and even the article author is missing, and there is no scale. We can improve the map if there is they have mentioned named locations in the map itself rather than using a bar graph as a statics. So it could be an improved version. That's it.
Hi everyone, this map shows the exact location where people have been attacked by magpie. For people who don't know what magpie is, it's a kind of bird, and these birds attack only during spring season for some reason. I think it's the mating season, I don't know. So yeah, as you can see in the map, there's no title, there's no scale, and the red symbol actually denotes people who got injured, and the yellow symbol is just people who just escaped. But then in the legend, the information is given wrong. There's a lot of unwanted stuff on top of the right map. The good thing is that the symbol they use for the bird denoting that's the bird, it's good, and it's very simple. Yeah. So be careful, guys. Thank you.
Hello everyone. This map is about the Hurricane Jerry. So September month has been a peak for all the hurricanes. Just after Humberto, it's now time for Jerry. So they have a predicted timeline or track when it will hit which places. So the map starts on 5 a.m. Thursday, and then it had a prediction of around 5 days. The good thing about this map is about I like the best thing is legend, because it says a lot of things about where are the high winds, where will be the winds with the less speed, that is with S, and what's the current position. They also have the latitudes and longitudes. The source is also mentioned in the map. The first, we don't find any title for the first map. There's no north arrow and scale. When we go to the second map, it's a kind of heat map, and we can see the scale where the hurricane is at the current position. So they have the intensity more, and the green has the intensity less. Okay, that's it. Thank you.
Hello everyone. These two maps show the energy structure is changing. We can see easily the energy structure, the new renewable energy is taking the main places. From the first picture, we can see the number of coal plants are increasing, but the number of solar and wind plants are decreasing. From the second picture, we can easily find the location and the capacity level of different types of plants. Both of them are clear district colors and points with different size, but they don't have the north arrow, and they don't have scale bar and no production information. Thank you.
Hi everyone, this news was posted by the News AU on September 20th, and the news says that last Friday is the most warmest day in 5 months, but the weathers will change on weekends. They use these two fingers to show the different temperatures in Australia. And for the good things, it provides the titles and sources of the data. And there are some necessary information such as the name of cities and the numbers of the temperatures. And the boundaries of different states also be provided. But there are some drawbacks. It is difficult to test or access because there is no URL and the dates of publication and the others. Also, it means the legend to show the meaning of different colors, and the scale bar and the nose arrow should be provided. Lastly, there is no information about name of different states and the relevant oceans. Thank you.
Hello everyone, this article is taken from CNN, and the map shows an eco-region in Brazil. Cerrado is suffering from deforestation. The map has a clear title, and it highlights its focus by only assigning colors to Brazil and leaves other regions in gray. The map has some comments on it which help readers to better understand the information, and it has source and author information. However, it is unclear what the light and dark red in the map means, as there is no legend for it. Also, the map contains no scale bar and no north arrow, and I think it would be better to also include the tree cover information, so then by contrasting the tree cover and the lost area, we can get a better insight into the severity of the deforestation. Thank you.
Just in time. So thanks to today's presenters. You can clap for all of them. I don't have time to clap in between. And I'll go to my laptop. And actually, before I continue with the presentation, I would like to an announcement, remind you about the industry dinner that is happening next Friday, 4th. I know you have a break, but you can still have a dinner. So I think the signing for dinner closes this Friday, so head to the announcements, and if you're interested to meet with some of the industry partners or even with me outside of the class, we can meet there. So keep that in mind. Okay, let's go to continue with the presentation. I'll skip these questions, but we can put them in a quiz if you're interested. So cardinal directions. So we had the topological relationships. Now we have cardinal directions. Generally speaking, north, south, east, west. That's what we know when we talk about cardinal directions. And there is some terminology when we can say how to actually define north or south or any other direction. So the first case would say there's a traditional view, how we look at the north, south, east, west. Half plane approach, the plane divided in half, anything that's above the line is north, anything that's below the line is south. We divide it this way, anything that is to the right of this line is east, left would be the west. That's the classic way how we can think about north. The second approach, so-called sectoral approach, we would say that within these 90 degrees going up, that all would be north. Northwest would be exactly this one line. This sector would be west. This sector would be south. And so on. Or in the third approach, we have the double cross, where we can say it's the extended object. If you think about the library, that I would take the width of the library and anything and use it as a double cross. For example, in directions north, east, west, south. So simple north, but we already have few different ways how to think about what's north, east, and west. Different ways of reasoning. And it can get even more complicated. So if you want to define a function in your GIS system, what's north of, you have multiple possibilities, different conceptual models. Generally, I'm not sure who said that example. If we said north from, half plane approach, anything that's above X shape would be north. I guess it's it has to be completely beyond X. However, what if the shapes are overlapping in some way? So we have this approach where we can see that if I can find a point in X and there will be a point in Y that is north from there, it can be so defined that the Y shape is north from X. However, there is a certain ambiguity in this definition. I can say can have a shape X and then shape Y. But what if the Y is more like that? In this case, I can find, use my point in X shape, I can find a point in Y shape that is north from the X. However, would you say that the shape Y is north? Not really. So there can be some ambiguity. I don't know what. See the shapes. So this approach, if I can find Y, point in Y, that will be north from X, may not always be the best. But it is one option. Another case, they've mentioned you can use centroids. Very good point. If the centroids are above a certain line, we can use them. Looking at the coordinates. The last approach I can show, but it's definitely not many, is that I'm using minimum and maximum case point pair. Means that if I can find the points, the maximum distance from the minimum points and find the direction of them, is it north? I can then decide and they are north. But this approach also has some drawbacks. Let's draw a different shape. So I have a shape X. And then I can have a shape Y. So this all is shape Y. So I can find a minimum and maximum distance. It's more of the thing. So the Y would be really wide. You see that? So would you say if I'm here that I'm north from X? Or would you say that I'm west? It feels more west. If this would be a path, a directional path, it would be more going west than north. So there can be still ambiguities in definition of north. But again, if you design a certain logic, it's good to stick with that. This is the minimum distance on the X. Let's say the minimum distance on X and the maximum on the Y. The furthest points far away from in the Y shape. Be those two. And the minimum on the X. There's more ways how to define north. This is just an example of a few. Very similar relative directions, but we'll use different language. So we're going from global, north, east, southwest, to local, which we would say relative, which is front, back, side, left. So objects like a table, it has its front, it has sides, and it would have the back. Or like you said, the library has a front, sides, and a back. So there would be the local reference frame. That's why reference frame is very important. We can have a global one, talking about north, east, west, or a global one when you can have front, right, back. But it's the same kind of directional models, but in a different scale. And then when we talk about the relative directions, the building was a very good example. So you can have the speed, talking about the viewer to my left, to my right, and my left. Or we can have the left from the church, left from the library. That's when it can get complicated. Because if you know the example with a tree doesn't have a front, side, or back, but a building has. So when I'm defining that it's to the right from the church or to the right from a building, I need to specify if it's my right or if it's the right of the building. Because there are two different faces. It's just to keep that in mind, and you need to be more specific with the language. So if I say the ball is to the left of the tree, it's obvious that it's the left from the speaker, from the viewer. But with the church, I would have to add additional information. Distance relationships, near, far, maybe talking that there's a different granularity. It's a matter of what we decide, what is near, what is far. There is not just one line which says that. For a system, we might want to decide that if this would be a distance, the chart on top. And at some point, it will stop being near and it will happen to be far. So I have a clear border over here. Yeah, but in reality, it's actually much more fuzzy relationship. If we would have a vote about what's near and what's far, so now I sit close to you, right? But if I come here, do you feel think I'm far, or am I still close? Still close. But if you would have a vote, and I would talk about the gentleman who's at the back of the room, would you say that I'm close to him or far from him? Far. Yeah. But depending on different context, because we're still in the same room, we can still think that we're close. So again, it would depend on what you decide. That's why it's fuzzy. And that's what this chart is showing. So if we would vote, let's say that 0 is nobody votes that I'm close to the gentleman, and 1 means that 100% percentage, 1 means that everybody would vote that I'm far to the gentleman. As we would change the distance, the voting would be different. So at some point we could all agree, at some point we could all disagree. However, everything in between is fuzzy. That's what needs to be decided. So we need to have a formal definition of what is near and what is far. So if I say Melbourne versus Sydney, do you think it's near or far? Melbourne and Sydney. Shout. Is it near or far? Far. Yeah. If you're saying it to somebody who's right now in Germany, do they think it's close? They might think, oh yeah, it's in the same country. Of course it's close. So the relative thinking about these terms matters. Also, there's a point about asymmetry. So we can say that the bike is near hospital, but you would probably not describe the location of a hospital that it's near somebody's bike. So keep that in mind. And let's just finish. So thank you for today. We'll put the questions in a quiz, which we had. So have a good week and a good break. And this week's labs, you actually go the step further and you'll start working on the practical use of what you've proposed. You will start doing it. So you can actually get some results. You can do some analysis. Have you drawn the cases?
Yes, but I noticed that there is an answer, but I can't understand this answer.
Okay, if you give me some time, I'll give it thinking myself and to create some examples, and I can maybe show it next week with some examples. I'll make a note about it. Okay, let me just pack all this, and you can chat about another time. But I really need to go. Because I'm interested. So you have a longer question, or do you have a quick question?
I'm just confused with the same question I answered.
With the 8. Well, I'm saying I'll look into it myself. It's a good question, and I maybe can prepare a slide for next lecture to show you the 8 cases with 2 lines.
Maybe you want to know what my confused one is?
Yes. I would definitely like to know that. That's why I was like, oh. What you can get. Great, do I have, is this all mine? To log out.
do.